that. The second tool we use in estimating costs is called parametric estimating. And in parametric estimating, what we do is that we go and check a unit of the previous project, not the full project, but only a unit of it. And then we compare from the new project with the previous project by unit wise. What does that mean? That means if I went to a project and said, to a previous project and said, it costed me to build this project, to build a square meter of this project, €1,000. And then I will come to the new project and I will say that the 1 square meter or the 1 cubic meter will cost me a similar amount. We use this when we know more information about the project, when we know more information about the quantity in the project, and when we know how much it costed us in the previous project per unit. And then we can use this technique, and it for sure has higher accuracy than the analogous estimating, and we use this kind of technique a lot in the projects usually. The third type of estimating is called, the third tool we can use in estimating is called the 3-point estimating. And this is actually not a tool of estimating rather than a tool of taking an average of estimates. So if I go to an activity and I want to estimate how much it costs for this one, then I might have a meeting with a technical department to discuss how much it might cost. There will be people that are too optimistic and give maybe lower numbers for the cost of this activity. And there will be people that are pessimistic and give higher estimates for this. And there is between them different people that gives the most likely estimate. And then in this tool, we have two types of distributions. The normal triangular distribution is the average of the three values. So we take the average of the optimistic, pessimistic, and most likely values. We divide them by 3. And there is something called beta distribution. And then we give more weight for the most likely. So we assume that because it is most likely value, then it should have more weight or should have more focus on it. Then we multiply it by 4, and instead of 3, we divide by 6. So which one we use? Usually we don't use the first one because the optimistic and pessimistic estimates might be too much too much far from the most likely. Then it will affect the final average. We use this a lot in the real world, and it has higher accuracy or higher estimation accuracy than the triangular distribution. One more tool we use here is called reserve analysis. And reserve analysis is something we put